we've not talked very much about gamma radiation. And gamma radiation is actually really, really easy to write the product for if that's the sole, decay. However, a lot of times gamma radiation is an additional byproduct of like maybe alpha or beta or some other radioactive decay. So the reason that's really easy is because it's 0, 0. So our big popular one is technetium. Let's do like technetium 43. The way you know that it's either even gonna undergo it, because look, if you just do it like this, you have the same thing, right? So what we do is we put a little M beside it for metastable, and I've also seen it with a star. But the M beside it with a metastable, what that means is that it is something that's radioactive, and all it has to do is give off a little bundle of energy. It doesn't actually change. It's just this is like a more excited state coming down to a not as excited state. And I shouldn't really use that terminology, but it's kind of the closest thing to what we're talking about. But this basically has more binding energy, and a little bit of it has been released in this case. Remember that gamma rays are much more energetic than X-rays. They can travel a lot farther. They can be stopped by lead, but I'm just saying they can travel a lot farther than X-rays. And then the other thing I want to mention is that we talk about, be careful on your skin or your body, that kind of stuff. But you should know that we use radioactive elements all the time for medicine. So we have right here, this one is used for PET scans. This is fluorine-18. It does positron decay. Look how short that half-life is. And if you think about it, in 10 half-lives is when something's basically considered dead. It means the radiation it's giving off is below background radiation. So, if you take that and you multiply that by 10, that's not even the number of minutes that are in a day. And this one is longer. This is 5 years. That's the first half-life. But this is for cancer treatment, sticking it inside of a tumor and closing up that tumor. Again, the beta decay is the key one there. It won't really do a lot. Of course, you do have to watch that gamma decay. But if it only gives off just a little bit, then, it's okay. Then we also have this one, and this gives off gamma decay. Notice that this has a half-life of 8 hours. And again, scans for everything. This is why they want you to be careful about some of the scans at the hospital. They might just keep an eye on you if you happen to have a lot of scans. PET scans, just all kinds of scans, brains, lungs, and hearts and bone. This one, if it's being used, you just don't want your counts of total radioactive to get too high. Radiation to get too high. And then thyroid. I'm sure you've heard about iodine being used in thyroid scans and treatment. And then we have thallium. This is an electron capture. And again, artery scans, cardiac tests. So, radioactivity can be a really, really good thing.